So, good evening, everyone. In this class today, we'll be discussing about the concept of the relative motion, right? So, we'll be discussing about how the motion is observed with respect to another observer, right? So, let's suppose we have this Cartesian system here. This is the Cartesian system here, right? That's our y-x plane. And let's suppose we have two particles. Particle 1 here, it's moving in this direction. Let's suppose it's moving in this direction. Particle 1 is moving here in this direction. Let's suppose it's moving with a velocity of VA, and there is another particle. It's moving in some random direction. Let me call its velocity as PP, right? Then the concept of relative motion is nothing. It's the motion as observed by another body, right? Or we can say it's just the velocity of one body with respect to another body, or we can say velocity of one body as observed by another body, right? So these are the two bodies with respect to this origin O. The velocity of this body A is VA in this direction, and velocity of this body B is VB in this direction, but with respect to the origin of this Cartesian system, right? But now the question is that what would be the velocity of particle A with respect to particle B, or what will be the velocity of particle B with respect to particle A? So now in this case, we are observing the two bodies when both the two bodies are moving with respect to some another reference, that's our origin of this Cartesian system, and we have to find their relative velocities or observe their relative motions with respect to each other, right? So if we define as the relative velocity, relative velocity is nothing, it's the velocity of one body as observed by another body, right? That's the relative velocity. And let's suppose we have to find the relative velocity of A with respect to B. That's velocity of A with respect to B. That's represented by VAB. That will be equal to nothing. That is VA minus VB vector, right? So this is nothing. This is the relative velocity of A with respect to B. Relative velocity of A with respect to B. This is the relative velocity of A with respect to B. And that's how the velocity of A will be observed by this body B, right? This is how the velocity of A will be observed by this body B. Similarly, we can also find the velocity of body B with respect to body A or particle B with respect to particle A. That will be given by VBA vector. That will be equal to velocity of B minus velocity of A, right? So it will be nothing VB vector minus VA vector. So this is nothing. It's the velocity of B with respect to A. Velocity of B as observed or with respect to A, right? So we can say that relative velocity of the relative motion is nothing. It's the vector subtraction of the two velocities, right? You can see that it's nothing. It's the vector subtraction of the two velocities. Vector subtraction of two velocities. Vector subtraction of two velocities. So that's how we calculate the relative velocities of two different bodies with respect to each other, right? So let's suppose that we have the condition number first, the case first, right? For the first case, let's suppose for same direction. For same direction, we mean that let's suppose that we have two bodies here. We have two bodies here, body A and body B, right? And both these bodies are moving along the same direction, right? And the velocity of A is VA with respect to ground, and the velocity of B is VB with respect to ground, right? Both these velocities are with respect to the ground, and they are moving along the same direction, correct? They are moving along the same direction, right? And in the previous concept that VBA, we said that it's a vector subtraction of the two velocities. And we know that whenever we calculate the vector subtraction of the two vectors, that's A vector minus B vector, modulus, that's always given as under root of A square plus B square minus 2AB cos of theta. Minus 2AB cos of theta. That is theta, where theta is the angle between the two vectors. Similarly, if we have to calculate VAB, VAB, VAB will be nothing. It will be equal to VA minus VB, VA minus VB. That will be equal to under root of VA square plus VB square minus twice VA VB cos theta. VA VB cos of theta, right? So this is how we'll be finding the relative velocities, magnitude of the relative velocities of the two particles, right? So it's nothing, it's the vector subtraction of the two vectors or vector subtraction of the two velocities, right? So similarly here in this case, we see that the two particles here, A and B, are moving along the same direction. If the two particles A and B are moving along the same direction, it means that the angle between these two velocity vectors, the angle between these two velocity vectors is going to be 0 degree, right? Theta will be equal to 0 degree. If theta is equal to 0 degree, we can write this VAB, that's nothing, that's equal to VA vector minus VB vector, right? VA vector minus VB vector. That will be equal to under root of VA square plus VB square minus twice VA VB cos of theta, right? That will be the uh, magnitude of this VAB vector, right? That's the mod of this VAB vector, right? So we know that for the two particles along the same direction, theta is equal to 0 degree and cos 0 is 1. So we'll be left with here under root of VA square plus VB square minus twice VA VB, right? Or we can write it as under root of VA minus VB whole square, right? VA minus VB whole square. That's equal to VA minus VB, right? So it means that whenever two particles are moving along the same direction, then their velocities is then their relative velocity is nothing. It's equal to the vector subtraction, or it's equal to the subtraction of the magnitudes of the velocities of the two bodies, right? So it's directly equal to VA minus VB. We'll be doing directly the algebraic vector subtraction if the two bodies are moving along the same direction, right? It means that, for example, that if VA is equal to 20 meter per second, right? 20 meter per second along east, right? Along east. And similarly, VB is equal to 30 meter per second along east, right? Along east. Then our mod of VAB, that's the velocity of A with respect to B, will be nothing. That will be equal to 20 minus 30, right? That will be equal to minus 10 meter per second, right? Minus sign here means that it will be along west, right? It will be along west, correct? So it will be along west. So 10 meter per second will be the relative velocity, magnitude of the relative velocity between V and VB. If V is equal to 20 meter per second along east and VB is equal to 30 meter per second along east, right? Now this case second is here. In the second case, that let's suppose that both these particles are now moving opposite to each other, right? With the velocities V and VB, they are moving opposite to each other. They are moving opposite to each other. It means that let's suppose V is moving in this direction, right? And VB is moving opposite to it in this direction, right? Then VAB will be equal to VA vector minus VB vector, right? VA vector minus VB vector. And we can see that since both the vectors are opposite in direction, then the angle between these two vectors has to be equal to 180 degree, right? 180 degree will be the angle between these two vectors. It means that modulus of VAB vector will be equal to under root of, that will be equal to under root of VA square plus VB square minus twice VA VB cos of theta, right? Cos of theta, and cos 180 is nothing, that's equal to minus 1, right? Cos 180 degree is equal to minus 1. We can plug in the value of cos 180 degree in this equation. We'll get under root of VA square plus VB square plus twice VA VB cos of twice VA VB, right? So we can write it as under root of VA plus VB whole square, right? So we'll be left with modulus of VAB, that's equal to VA plus VB. So it means that the two velocities simply get added when the two particles are moving in the opposite direction, right? And the two velocities simply get subtracted if the two particles are moving along the same direction, right? So for opposite direction, the relative velocities will be VA plus VB, and for the same direction, relative velocities will be VA minus VB, right? VA minus VB. Now let's move on to the next concept here. What happens to the equations of motion in case of relative motion, right? If we are observing the two bodies relatively, right? In case of relative motion, then what happens to the equations of motion, right? Then equations of motion become also relative, right? We use V is equal to U plus AT, right? Now we'll be using in this case as V relative must be equal to U relative plus A relative multiplied by the time, right? Or similarly, we can use relative displacement as U relative T plus half A relative T square, right? Or we can write it as V relative square must be equal to U relative square plus 2 times A relative S relative, right? So S relative is nothing, it's a relative displacement, and U relative is the initial relative velocity, and A relative is the relative acceleration, right? So A relative here is nothing, it's the relative acceleration, right? Relative acceleration. And how will we define the relative acceleration as? Relative acceleration will be nothing. Suppose uh, A is moving with acceleration A, and B is moving with acceleration AB, right? Then the relative acceleration will be acceleration of A with respect to B. That will be nothing. Acceleration of A minus acceleration of B, right? And similarly, the relative displacement will be nothing. That will be a displacement of A, right? Minus displacement of B, right? So that will be the relative displacement, right? And the relative acceleration, right? Let's discuss this simple problem here, right? Simple illustration. Buses A and B are moving in the same direction with speed 20 meter per second and 15 meter per second respectively, right? They are moving in the same direction with speeds 20 meter per second and 15 meter per second respectively. Find the relative velocity of A with respect to B, right? And relative velocity of B with respect to A, right? So these are moving in the same direction, right? A and B are moving in the same direction. A is moving with the speed. Both are moving with the speed equal to 20 meter per second, right? 20 meter per second. This is also moving with the speed of 20 meter per second. Then their relative velocity, that's VAB, will be equal to nothing since they are moving along the same direction, right? This B is moving with in the same direction with speeds. B is moving with 15 meter per second, right? So VAB will be nothing. That will be VA minus VB, right? It will be simply the subtraction of the magnitudes of the two velocities because they are moving in the same direction. So that will be equal to 20 minus 15, right? That will be equal to 5 meter per second, right? 5 meter per second, right? And now we have to calculate find the relative velocity of B with respect to A. So that will be equal to VBA. That's VBA vector. That will be VB vector minus VA vector, right? Since they are moving in the same direction, so it means that we'll just write it as VB minus VA, right? VB minus VA, correct? So VB is 15 and VA is 20. It will be equal to minus 5 meter per second, right? It means that if the relative velocity of A with respect to B is along east direction, then the relative velocity of B with respect to A has to be along west direction, right? It will be opposite to the direction of the relative velocity of A, right? So let's move on to the next question. A man A moves in the north direction with a speed 10 meter per second, and another man B moves in uh, east 30 degree of north, right? East 30 degree of north, right? Find the relative velocity of B with respect to A. It means that let's draw the situation here, right? A man A moves in the north direction, so man A is moving along the north, right? With a speed of 10 meter per second. So I can write it as 10 meter per second, but the direction is along north. I can write it as j cap, right? And another man B moves in east direction, right? In east 30 degree of north, east 30 degree of north, right? So it means that it will be like this. It's making an angle of 30 degree with the east here. So this is the 30 degree here, right? With a speed of 10 meter per second, right? And this is the speed of or the velocity of B, right? And we can resolve this velocity into two components. For this body P, one component will be along this, another component will be along this, and this component has to be equal to 10 cos 30 degree, right? That will be along I cap, and the another component here, it will be equal to 10 sine 30 degree. It will be along j cap, right? It will be along j cap, right? So it has to be along j cap. So it means that 10 cos 30 degree will be equal to 10 multiplied by root 3 upon 2. That's I cap, right? Or we can write it as 5 root 3 I cap. And this Vy component or the vertical component of this Vb velocity will be equal to 10 upon 2 j cap. That will be equal to 5 j cap, right? 5 j cap. So our Va, we can write it as Va is nothing, that's equal to 10 j cap, right? We can write it as 10 j cap, and we can write this B as now 5 root 3 I cap, right? And plus 5 j cap. And we have to find the velocity of B with respect to A. It means that we have to find VBA. That will be nothing. That will be equal to VB vector minus VA vector, right? VB vector minus VA vector, right? So it will be 5 root 3 I cap plus 5 j cap minus 10 j cap, right? So 5 root 3 I cap minus 10 j cap, right? So it will be 5 root 3 I cap, and 5 j cap minus 10 j cap will be 5 j cap, right? So this will be the relative velocity, that's VBA vector, right? And we can plot this 5 root 3 A cap minus 5 j cap. It means it's one component along the positive x direction and another component along the negative y direction. It means that the direction of this VAB has to be the direction of this VAB has to be along the direction of this VAB. VAB will VBA will be along this, right? So this will be the direction of VBA, right? This will be the direction of VBA, right? Because there is a component of VBA along x direction and another component is along minus y direction, right? So this is how the VBA will be, right? Now let's move to the next question. The question is, Delhi is at a distance of 200 km from Ambala. Car A sets out from Ambala at a speed of 30 km per hour, and car B set out at the same time from Delhi at speed of 20 km per hour, right? When will they cross each other? What is the distance of that crossing point from Ambala, right? So we have two cars, like a car A and we have another car B, right? Two cars, car A and car B, they are moving in the opposite direction, right? They are moving in the opposite direction, right? So the car A has been given with a speed of 30 kilometer per hour, right? And the speed of car B is 20 kilometer per hour, right? It's 20 kilometer per hour. And the distance between, it's given that Delhi is at a distance of 200 kilometer from Ambala. It means that the distance between these two cars has to be equal to 200 kilometers, right? 200 kilometers, correct? And they are not accelerating at all. So acceleration of both the cars is equal to zero, right? They are going with the constant speed of 30 kilometer per hour and 20 kilometer per hour. Now the question is, when will they cross each other? So we have to find the time when they will cross each other, right? So the time will be nothing. Time will be nothing. That will be equal to, time will be equal to whatever the relative speed is there, right? Time will be equal to this total distance, right? Total distance to be covered, right, by these two cars A and B, that's equal to 200 kilometer, right, upon the relative velocity between them, right, upon the relative velocity between them. So it will be 200 upon, since they are moving in the opposite direction, right, since they are moving in the opposite direction, it means that their relative velocity, that's VAB will be nothing, that will be equal to VA plus VB, right? VA plus VB, that will be equal to 30 plus 20, that has to be equal to 50 kilometers per hour, right? So it will be equal to 50, and 200 upon 50 is equal to 4. It means that they will be meeting each other after time equal to t equal to 4 hours, right? Time t equal to 4 hours, and in that time, in time t equal to 4 hours, what is the distance of that crossing point from Ambala, right? From Ambala, we have to calculate the distance, right? It means that from Ambala, after 4 hours, the car B must have traveled a distance. Let me call this distance as S1, right? This distance S1 will be time, that's 4 hours, multiplied the speed of this car B, that's 20. That will be equal to 80 kilometers, right? So it means from a distance of 80 kilometers from the Ambala, these two cars are going to meet each other, right? Another question is here on the screen. The two trains A and B, which are 100-meter and 60-meter long, are moving in opposite directions on parallel tracks, right? Two trains, A and B, which are 100-meter and 60-meter long, are moving in opposite direction on parallel tracks, right? There are two trains. Let me call this as train A, right? This is train A. And another train is there, train B, right? This is train B. This is train B. They are moving in the opposite direction, like this. They are moving in the opposite direction. And the length of the train A is given as 100 meters, and the length of this train B is given as 60 meters, right? Velocity of the shorter train, that's the 60-meter train, is 3 times that of the longer one. Let's suppose the velocity of train A, which is the longer train, is V, then the velocity of the shorter train is 3V, as given in this question, right? As mentioned in this question, right? So it means that uh, is 3 times that of the longer one. If the trains take 4 seconds to cross each other, find the velocities of the trains, right? If the trains take 4 seconds to cross each other, then find the velocities uh, of the trains, right? It means that these two trains are moving in the opposite direction, right? They are moving in the opposite direction. It means that when they are going to cross each other, right? It means they are going to cross each other when the tail of train A will coincide with the tail of train B, like this. So train A will be here and the train B will be here like this. And train A is moving here with speed B and train B is moving here with speed 3V, right? So that's when they will be crossing each other. And in this time, the train A or the train B must have covered a distance of 100 meter and the 60 meter together, right? 100 meter and the 60 meter together. It means that the total relative distance traveled by these two trains A and B will be equal to 160 meters, right? That's when they will be crossing each other, right? And their relative velocities will be nothing. Relative velocities will be nothing. It will be VA plus VB because they are going in the opposite direction. And the speed of A is given as V and the speed of B is given as 3V. So their relative velocity has to be equal to 4V, right? And the time will be nothing. It will be the distance upon the relative velocity, right? V relative. So distance is 160 meters, right? That's upon the relative speed, that's 4v, and the time it takes to cross each other is 4 seconds, right? That's equal to 4 seconds. So it means that our velocity v from here will be nothing equal to, it will be 160 upon 4 into 4, right? That's equal to 10 meter per second, right? 10 meter per second, correct? So if v is equal to 10, va is equal to 10 meter per second, right? And then vp is 3 times va, right? That will be equal to 30 meter per second. That's 3 into 10. That will be equal to 30 meters per second, right? So this is the speed with which both the trains must be traveling, right? Train A is moving along right direction with the speed of 10 meter per second, and train B is moving along left direction with the speed of 30 meter per second, right? Let's discuss the similar another question here, right? Two trains A and B each of length equal to 50 meters, right, are moving with constant speeds. If one train A overtakes the other in 40 seconds while crosses the other in 20 seconds, now find the speed of each train. You can see in this diagram that there are two trains. One is train A, another is train B, right? There are two situations. I call this as case first, that's case A, and this is another situation. Let's call this as case B, right? In the case first, the train A overtakes train B, right? Train A is trying to overtake train B, and it overtakes the train B in the time equal to 40 seconds, right? In 40 seconds time, train A is overtaking the train B, right? So it means that their relative speeds will be, since it will only overtake train B if V1 is greater than V2. If V1 is not greater than V2, then train A is not going to overtake train B, right? So V1 has to be greater than V2, correct? So when this train A overtakes train B, it must have covered a relative distance of the relative distance equal to the length of the two trains, and the length of each train is 50 meters. So the total length it must have traveled by this train A relative distance, that will be equal to 100 meters, right? That will be equal to 100 meters, and their relative speed will be equal to, since they are moving along the same direction, that will be equal to v1 minus v2, right? So the time will be nothing. Time will be equal to distance upon the v relative here, right? So time is 40 seconds in this case. 40 will be equal to 100 upon v1 minus v2, right? So you can see from here. So 4 times v1 minus 4 times v2, right? That will be equal to 10. Or we can say that v1 minus v2 will be equal to 5 upon 2, right? Let's call this as equation first, right? Let's call this as equation first. In the case second, what happens is that now they are moving in the opposite direction, right? They are also crossing each other, but in the opposite direction, right? Now in this case, once again, they will be covering the same relative distance, that will be equal to 100 meters, right? But now the relative velocities will be different. It will not be the same. Now they are moving in the opposite direction. Their relative velocities will be v1 plus v2, right? So the time will taken will be different now. Let's call that as t dash. That will be distance upon the relative speed. That's v1 plus v2, and the distance is 100 meters again. V1 plus v2, and the time taken by them is equal to 20 seconds, right? 20 seconds. So it will be 25, right? So it means that v1 plus v2 now will be equal to 5, right? That will be equal to 5. So this is our equation second, right? We can just add these two equations. If we add these two equations, what are we going to get? It means 2i's v1 will be equal to 5 upon 2 plus 5, right? So it will be 10, 15 upon 2, right? 15 upon 2. So from here, it means that v1 will be equal to 15 upon 4 meter per second, right? 15 upon 4 meter per second. And similarly, v2 will be equal to 5 minus 15 upon 4, right? That will be equal to 5 upon 4, right? That will be equal to 5 upon 4 meter per second, right? So that will be the speeds of the two trains, right? The speed of the first train will be 15 upon 4 meter per second, and the speed of the second train will be equal to 5 upon 4 meter per second, right? Now let's move on to the applications of the relative velocities, right? One of the important application of the relative velocity is rain and man problem, right? Rain and man problem, right? So you know that whenever we are moving outside, right, and the rain is falling, then what we do is that we also move with some speed, right? We're moving, running, or moving with some speed, right, with respect to the ground. And let's suppose I call that speed of the man with respect to the ground as the speed of man with respect to the ground as Vm, right? So Vm is the speed of the man with respect to the ground, right? And Vr is the velocity or the velocity of rain. Vr is the velocity of rain with respect to ground, right? Velocity of rain with respect to ground, with respect to ground. See, if we are not moving, we are at rest, right? We are at rest. Then in that case, the rain is going to fall vertically, right? Vertically downwards, right? If we are not moving, right? If we are at rest, then the rain is definitely going to fall vertically on us, right? Vertically downwards. But what happens when we are also moving and the rain is also falling down, right? In that case, what is going to happen? This relative velocity or the direction of the rain or the relative velocity of the rain will be different, right? Or the velocity of the rain as observed by the moving man, right? Moving person will be different as the velocity of the rain observed from the ground, right? So that's what we will be discussing about the rain and man problem, right? In this case, and it's one of the important problems, right, with respect to the relative velocities. So let's discuss it one by one, right? Let's discuss it one by one. The condition first is that if rain is falling vertically with a velocity of Vr, right? Velocity of Vr, and an observer is moving horizontally with a velocity of Vm, right? Then the velocity of rain related to observer will be, right? It means that let's suppose that velocity of rain is in vertically downward direction, right? Like this. Let's call this as VR, right? VR vector, right? VR vector. And the man is moving in the horizontal direction like this with respect to ground. We call that velocity as Vm. This is the velocity of man, right? Vm is nothing. It's the velocity of man. This is the velocity of man. And VR is nothing. It's the velocity of rain. Velocity of rain. And the rain is falling vertically downwards with respect to the ground, right? And the man is moving in horizontal direction with respect to the ground, right? Now we have to find how the man is going to observe the rain falling, right? How the man will observe the falling rain, right? So it means that we have to find the velocity of rain with respect to man, right? Velocity of rain with respect to man will be nothing. It will be velocity of rain minus velocity of man. That's nothing. That's the relative velocities of the two objects, right? So it means that it's the velocity of rain that's in the downward direction, right? That's in the downward direction. Or we can say VR vector is nothing that's equal to minus VR j cap, right? We can write it in vector form as minus VR j cap. Minus Vm. If this is Vm, then the minus Vm will be in this direction, right? This will be minus Vm, right? This will be minus Vm. It means that if this is minus Vm, it means that the person standing here, right? The person standing here will observe this rain falling along this direction. Now, this will be the direction of the relative velocity. So, this is velocity of rain with respect to man. So, man will be observing the velocity falling in this direction. So, rain will be falling along this direction, right? So, man will observe the rain falling like this, right? In this direction. So, this is how the man is going to observe the falling rain, right? Along this. With respect to ground, the rain will be falling like this. With respect to the ground, the rain will be falling like this. But the velocity of the rain as observed by this moving man will be like this, right? So it means that to protect itself or protect himself from the rain, from the falling rain, this person has to keep the umbrella like this, right? Then only this person will be able to protect itself from rain, right? So he has to keep this umbrella like this. It means the person here at this point has to keep the umbrella exactly opposite to the direction of the relative velocity of rain with respect to man, right? So if the VRM is in this direction, then opposite to that direction, the person has to keep the umbrella, right? Then he will be able to, then he will be able to protect itself himself from the rain, right? And let's suppose that at an angle of theta here, right? At an angle of theta with the horizontal, right? At an angle of theta, he has to keep umbrella at an angle of theta with respect to the horizontal, right? If this angle is theta here, right? If this angle is theta here, then this angle is also equal to theta here, right? This angle is also equal to theta here, right? Then we can calculate this angle. Then this angle will be nothing. This angle will be nothing. We can write here as the tan of theta. Tan of theta will be nothing. That will be the perpendicular, right? That will be the perpendicular upon the base. The perpendicular will be mod of VR, right? Upon mod of VM, right? So that's the angle. It means that VR upon VM will give us the angle at which this person has to keep this umbrella in order to protect himself from the falling rain. From here, the theta will be equal to tan inverse of VR upon VM, right? VR upon VM, correct? VR upon VM. So this is how the person will keep its umbrella with respect to the horizontal in order to protect himself from the rain, right? The case second is that if rain is already falling at an angle with the vertical, right? At an angle with the vertical with a velocity of VR, and an observer is moving horizontally with speed VM, finds that the raindrops are hitting on his head vertically downwards. It means that the condition is like this. The condition is like this. It means that the person is standing here, right? The person is standing here, right? The person is standing here. In this case, actually, with respect to the ground, the rain is falling at an angle, right? Rain is falling at an angle, right? Let's suppose, with respect to the ground, the rain is actually falling like this at an angle of theta, right here, at an angle of theta. So this is the direction of rain with respect to the ground, right? But what this man is observing is that this man is itself moving along the horizontal direction with velocity Vm, right? That's the velocity of man with respect to the ground. But what this man is observing that this rain is actually falling like this, right? In the vertically downward direction. And with respect to the ground, the rain is actually falling like this, right? But this man, while moving, observes that rain is falling like this, right? In the vertical direction, right? In the vertical direction. So it means that if this is the VR and this is the VM, then VRM, we can resolve this VR into two components. One component will be this. We call this component as it will be VR sine of theta, right? This will be equal to VR sine of theta along I direction. I call it as I cap, right? And this component will be VR cos of theta, VR cos of theta along minus J direction. That's minus J cap, right? So with respect to ground, we can write this VR vector as VR sine of theta, right? I cap minus VR cos of theta J cap, right? And with respect to ground, this man is actually moving along this direction. So we can write this as Vm I cap, right? Vm I cap. So velocity of rain with respect to man, velocity of rain with respect to man will be nothing. That's the Vrm, right? Vrm. That is Vr vector minus Vm vector, right? That's Vr vector minus Vm vector. So it will be equal to Vr sine theta I cap minus Vr cos of theta j cap, right? and minus Vm, that's minus Vm I cap. Or we can rearrange it like this. So it will be Vr sine theta minus Vm I cap and minus Vr cos of theta j cap, right? So this will be the VRM, right? This will be the VRM. But the condition here is that this rain appears to be falling vertically downwards with respect to the man which is moving along the horizontal direction. It means that with respect to the man, the rain has no horizontal component. Because with respect to the man, the rain is falling vertically downwards. It means with respect to the man, the rain is not having any horizontal component. It's only having the vertical component. It means that with respect to the man, the horizontal component must be equal to 0. It means that if horizontal component is 0, it means that this component must vanish. That's Vr sine theta minus Vm should be equal to 0, right? It means that we get a condition for this thing to happen. The condition is that sine of theta will be equal to Vm upon Vr. So this is the condition at which this is going to happen. With respect to the ground, the rain will be falling in this direction at an angle of theta, but with respect to the person which is moving horizontally with a speed of Vm, the rain appears to be falling with respect to this person vertically downwards. It means that it's having a zero horizontal component, and the condition for that will be the horizontal component will be equal to 0. It means that Vr sine theta minus Vm has to be equal to 0. But the condition for this to happen is sine theta is equal to Vm upon Vr. So this is the condition at which this condition will be observed by this moving man, right, with respect to rain. And it will appear for this moving man that the rain is falling vertically downwards, right? But actually, with respect to the ground, the rain is actually falling at an angle of theta, right? So let's stop here. In the next class, we'll be giving a brief about the man and river problem, right? Swimmer's problem. That's also part of relative velocity. We'll be discussing that in the next lecture, right? So we'll stop here and we'll discuss river or boat problem, or we say sometimes swimmer and river problem in the next lecture, right?